All right, so welcome to the first lesson of IB. This is a kind of a multiple parter, but we're going to start off with stuff that you've done before in maybe middle school. And we're going to go ahead and start off with rounding. All right, just had to do a little bit of adjusting. Okay, so we're starting off with rounding. So it says round to two decimal places. So what that means is to the right of the decimal point. So the second decimal place has the number 7 in it. So to round to 7, which is the hundredths place, we want to look at the number to the right. So we see that 8. So we say 5 or above. We're going to give it a shove, like we're going to add 1 to it. And then 4 or less, we're going to let it rest. Okay. So since that 8 is 5 or above, that means that this 7 is going to go up 1. So that's going to go to 8. Everything to the left of it stays. So it's going to be 5.6. And then everything to the right of what we just rounded to drops. Okay. So 5.68 is our answer. And hopefully that is a review. The next thing we're going to be going ahead over is significant figures, and that's how precise a number is. This really comes in handy to know which numbers are non-zero, and so non-zero numbers are numbers like 1 through 9, and 0 is obviously a 0. Okay, so let's go ahead and take a look at the three rules that we have. So zeros to the left are not significant. So what do I mean by that? You see question number 2 right here. These zeros to the left, they're to the left of the non-zero number. They are not significant. What does that mean? That means that 2 is our only significant number. So there's one significant number. Okay. Zeros to the right are significant. So what does that mean, right? These two zeros are to the right of the 7. So since they are significant, there are three significant numbers. They are 7, 0, and 0. Okay. And the third rule is non-zero sandwich, right? So like it makes a non-zero sandwich. So what does that mean, right? You see the 0 right here. It's in between two numbers that are non-zero. So that means that it is significant. So let's take a look and see how many numbers here are significant. Okay. So we know that the 5 is significant because it is a non-zero number. So the 5 is significant. The 0 is in between two non-zero numbers, so that makes that significant. So that's two significant numbers. 4 is non-zero, 3 is non-zero, and 8 is non-zero. So now let's check this 0 right here, right? We have to go back to rule number 1. Zeros to the left are not significant. So there are 1, 2, 3, 4, 5 numbers that are significant here. Okay. And going back to the first one, let's go ahead and apply all three of our rules. So we don't have any non-zero sandwiches. Okay, so let's take a look. We have that significant, the 2, the 5 is significant, the 3 is significant, all of them because they are non-zero numbers. And then it says zeros to the right are significant. So that 0 is significant. So that means that there are 4 significant figures. Okay, all right. The next thing we're going to do is review something that you've done in middle school. It's called scientific notation. And that's where you have a number that's between 1 and 9. You're going to have a decimal point, you're going to have other numbers, and then you're going to have times 10 to an exponent. Okay, so this is what it looks like. So we'll take a look and we'll do an actual problem. So we can take a look at this problem that we have with question number 1. This is a very big number, right? Right? So when we look at this number right here, what we want to do is we want to see what's the first number from left to right. We always want to go from left to right. And we want to see the first number that we have that's between 1 and 9. So I can look at the first number, and that's 3. So I'm going to put a 3 down. I'm going to put a decimal point. And then I'm going to put all the numbers to the right that are significant. So I'm going to put 5, 2, 8, 0, 4. These zeros to the right are placeholders, so I don't need to write them down. And then they're times 10. And then I want to see how many times do I have to move the decimal point. So right now the decimal point is at the end, if this was money, and I want it to be between the 3 and the 5. So I want to see how many times I have to move it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 place movements. So I'm going to put that exponent as 10. Okay. So again, you look from left to right, the first number that you have that's between 1 and 9, just going back to what we wrote up here. Write down all the other numbers, put times 10, and then count decimal places to see how many times do you need to move it from the end to between the 3 and the 5. Okay. For question number 2, we have the opposite. We actually have a very small number. So we want to look again from left to right and find the first number that we have that is not a 0. So I see a 2. So I'm going to put a 2 there. I'm going to put a decimal point. I'm going to put the numbers to the right. I'm going to put times 10. And then the decimal now is here. Okay. I want to move it between the 2 and the 1. So I have to go 1, 2, 3, 4. So that's 4 times to the right. So that is going to be -4. Okay. So if I'm moving it to the right, it's going to be a negative number. If I'm moving it to the left, it's going to be a positive number. So pause, take some notes. And the reason why we use this is because there are very large numbers or very small numbers. And so this is just an easier way to write it. All right. So the last thing that we're going to do on this page is we're just going to talk real quick about what are some numbers and why should you care. So like, for example, like the speed of light, right? That's how quickly the light, when it turns on, adjusts and goes to your eyes, or that it moves. So that number is 3 times 10 to the 8th, and that is meters per second. Okay. That's very quick, very fast. Okay, Avogadro's number you might hear in chemistry, and that is symbol Na, and it's equal to 6.02 times 10 to the 23rd, and the units are going to be atoms per molecule. Atoms per molecule. Okay. And that also is a very large number. Okay. The gravitational constant is 6.67 times 10 to the -11. What do you think that number is? Very big or very small? If you said very small, you are correct. So just a couple of things. You don't need to memorize these numbers. It's just if you see it, you know, okay, what scientific notation is, and if the number is very large or very small. And the pro tip is you're always going to go to 3 significant figures if it's not specified. If not specified, okay? So that is everything for this page. There are some things about bounds. I'm going to go ahead and just go through a problem with you. So this is a worked example. So what we want to do is just this first part right here, okay? So we want to see if I have 14.3 on a number line. Here's 14.3. I want to find out all the numbers that round to 14.3, okay? And I want to go to 1 decimal place. So 1 decimal place. So what does that mean? Okay, that means that I want to go with its accuracy to that point right there, which is the 10th place. Okay, so how do I do that? Let's take a look at this. So let's throw some numbers out, right? 14.4. Does that round to 14.3 when I'm going 1 decimal place? No, it doesn't. It rounds to 14.4. Okay. How about 14.39? Does that round to 14.3? That doesn't, right? Because if I'm going to this decimal place, the 9 tells me it's 5 or above, so that's going to round to 14.4. I don't want that. I want it to round to 14.3. How about 14.33? Does that round to 14.3? And the answer is yes, right? I'm looking at this decimal place. I look at one number to the right. So this is 4 or less, so I'm going to let it rest. Okay, so 14.33 is part of the solution. Okay. So what are all the numbers that round to 14.3? Let's take a look at it, right? It goes up to 14.4, but it's not including 14.4, right? So we also talked about 14.39. That doesn't round to 14.3. right? 14.39 rounds to 14.4. All right, so I want you to do a little bit of like experimentation, and let's see what happens. So let's take this 14.4. We can leave that there. So let's see what number do we go up to. All right, so let's think about this. So if this number right here were a 5, 14.35, would that round to 14.3? No, because 5 or above, we're going to give it a shove, right? So it goes up to 14.35. So like right here, if I were to go ahead and let me do this in purple so you can see. So 14.35 is going to go up to that point, but it cannot include 14.35. So the upper extreme is going to be 14.35, but we want to go less than that. So if our number was, for example, 14.349, and I go to that 10th decimal place, right? To the tenths. This number is a 4, so that means that the 3 would rest, okay? So the largest number that I can have is 14.35. And then I want to go ahead and put my X here. And then I want to see what is my smallest number that I can have. All right. So if I have 14.2, would that round to 14.3? You should look like, no, absolutely not. If I had 14.24, would that round to 14.3? No, it would not, because 4 or less, we're going to let it rest, okay? So what if I did 14.25? Yeah, right? Look at that, right? I'm looking one number to the right, 5 or above, I'm going to give this a shove. This is going to move up one. So that's going to round to 14.3. Cool. So we have 14.25 is going to be our smallest number. It's going to be including that number. So our numbers that round to 14.3 are right here. It's between 14.25, including that number. And then the largest number we're going to have is up to 14.35, but we're not including it. Like we don't have this little equal sign on the bottom over here. Okay. I hope that makes sense. There are a couple of more examples here. There's a more like mathematical way to do it if you like a formula. So you can go ahead and take a look at this, look at the couple of examples, and I'll always have the answer like put it into a rectangle for you, so that way you can figure out what your answers are for sure. Okay. So practice this. If you have any questions, let me know. Good job.